Deep dive into scikit-learn's pairwise kernel for Gaussian processes. The pairwise kernel in scikit-learn's Gaussian process GP framework is a versatile tool for constructing kernels that operate on pairwise distances between data points. It provides a flexible and powerful way to model complex relationships in your data, especially when dealing with nonlinear dependencies. Here's a comprehensive breakdown of PairwiseKernel, covering its key features, use cases, and implementation details. 1. What is a kernel in Gaussian processes? Before we delve into PairwiseKernel, let's understand the role of kernels in Gaussian processes. In essence, a kernel defines the similarity or relationship between pairs of data points. It provides a way to measure how close two data points are, considering both their individual features and the underlying structure of the data. 2. The pairwise kernel combining kernels with distances. The pairwise kernel allows you to build kernels based on a distance metric between data points. It takes two main components. Metric. This defines the distance function used to calculate the distance between data points. Common choices include Euclidean distance, the straight line distance in Euclidean space. Manhattan distance, the sum of absolute differences between coordinates. Chebyshev distance, the maximum difference between coordinates. Cosine distance measures the angle between two vectors. Hamming distance counts the number of differing bits between two binary strings. Kernel. This is a function that takes the calculated distance and transforms it into a kernel value, representing the similarity between the data points. Common kernel options include RBF, radial basis function, the most widely used kernel. It decays exponentially with increasing distance, implying that closer points are more similar. Laplacian, similar to RBF but with a different decay rate. Linear, a simple kernel that assumes a linear relationship between data points. Polynomial allows for nonlinear relationships by raising the distance to a power. 3. Usage and implementation. Here's how you can use the pairwise kernel in scikit-learn. Python. From sklearn, Gaussian process, kernels. Import PairwiseKernel. RBF. Define the kernel. Kernel PairwiseKernel metric Euclidean. Kernel RBF length scale 1.0. Create a Gaussian process model. From sklearn, Gaussian process. Import Gaussian process regressor. GPR Gaussian process regressor kernel. Train the model. GPR. FitXtrain. Y-train. Make predictions. YPREDGPR. PredictXtest. This example demonstrates how to combine the Euclidean distance with the RBF kernel. You can readily customize the metric and kernel parameters to achieve the desired behavior. 4. Advantages of the pairwise kernel. Flexibility enables you to construct kernels based on various distance metrics and kernel functions. Intuitiveness. The underlying concept of measuring distances between data points is easily interpretable. Scalability. It can be effectively used with large datasets by utilizing efficient distance calculation algorithms. 5. Considerations and limitations. Computational cost. Computing distances between all data points can be computationally expensive, especially for large datasets. Choice of metric and kernel. The choice of metric and kernel significantly impacts the model's performance, and it requires careful consideration based on your data and problem. Data scaling. It's often crucial to scale your data before using PairwiseKernel to avoid bias introduced by different feature scales. 6. Examples and applications. Image recognition. The PairwiseKernel can be used to model similarities between images based on their pixel intensities or other features. Text classification. It can capture relationships between text documents based on word frequencies or other textual representations. Time series analysis. The pairwise kernel can be employed to model the temporal relationships between data points in a time series. 7. Advanced concepts. Kernel hyperparameters. The pairwise kernel often involves hyperparameters like length scale in RBF kernel that control the kernel's behavior. These hyperparameters can be optimized using techniques like cross-validation. Composite kernels. Multiple pairwise kernel instances can be combined to create more sophisticated kernels, allowing for richer representations of the data's underlying structure. In conclusion, the pairwise kernel in scikit-learn provides a powerful and flexible tool for building custom kernels in Gaussian processes. Its combination of distance metrics and kernel functions allows you to effectively model complex relationships in your data, making it an invaluable resource for a wide range of machine learning applications.